Okay, this is the Unit 6 study guide. We're just going to go over the answers. I showed most of the work, so if you need to look, you can stop the video and look at the steps. Okay, the first one, simplify each. Answers must have positive exponents. Remember, if you have a negative exponent, it goes to the opposite place, and then you change it to positive. So 1 is x to the 9th over y to the 6th. I'm going to go across. The numbers came out screwy. 5 is negative 4/3 x to the 12th, or you can write it negative 4x to the 12th over 3. 2 is y to the 4th over x to the 8th. And then across the hall here, 6, 8x to the 13th over 9. This is how you can write number 5 too. I would take either way. Number 3, this is division. Remember, when you're dividing, you're subtracting the exponent. So this is 3y over x to the 4th. Number 7 is 1 over x to the 4y power. Anything with a negative exponent goes to the opposite of where you started, and you make it positive. 4, 3y squared over x to the 6th. And then across the hall, 8, 1 over y to the 8x power. Let me see if I missed something here. Okay, on to the next page. All right, remember you have to get to the same base so that you can cancel out the bases and then just solve. When you cancel out the 8s, you have x plus 3 equals 3x. When you solve that, x is 3/2. Number 2, you cancel out the 2 because you have a common base, and you have 5x equals x minus 8, and you solve to get negative 2. Up here, 7, I made 125 into 5 cubed, but then you have to multiply that by the exponent that's already there. So I have 3y plus 6 equals 3y minus 1, which ends up being no solution. Number 8, I made 16 into 2 to the 4th power. So then you end up with 4x plus 20 equals 4x plus 20, which is infinite solutions. Number 3, you have to think here with this fraction of what it was before, which would mean it had a negative exponent. So it became 3 to the negative 1st power, and you have to multiply that by the exponent. You get negative 3 equals x plus 12, and when you solve, you have x equals negative 3. Number 9, I made everything into a base of 3, which means this you had to multiply your exponent by 2, and this you had to multiply your exponent by 3. So I end up with 3 to the 2x plus 1 plus 2x plus 10 equals 6x. When you solve, you have 11 over 2. Same here, I made everything into the base of 2 so I could cancel that out. So I have 2x plus 2 plus 2x plus 5 equals 9x. When I solve that, I have 7/5. Remember, when you're multiplying exponents, you're adding them. So remember, these are exponents we're dealing with after you cancel out the base, so you got to follow the rules for exponents. Number 5, we're dividing, so we're going to find the same pace and we're going to subtract. I made everything into a base of 2, so I have 6x plus 3 minus, and this has to go in parentheses, the quantity of 3x plus 4 equals x plus 5. When you solve, you get 3. Number 6, I made everything have a base of 3. I compensate by multiplying whatever you had to, what power it goes to. Then I subtracted to divide. So I have 6x plus 6 minus the quantity of 3x plus 4 equals x plus 2. When you solve, you get 0. Number 11, I made 256 into 2 to the 8th and 8 into 2 to the 3rd. Then I subtracted, and I got 16/5. All right, graphing exponential functions. You always are going to make this table. So I'm going to use 1 over b, 1 and b. So remember, the h affects the x, the k and the a affect the y. Your asymptote is your k. So your new x's are -1, 0, 1. Your new y's are 1/4, 1, and 4. Your domain is -∞, ∞. Your range is 0, infinity. Your asymptote is y equals 0, and there are no transformations occurring. There's your graph. The next one, did I get this right? Oh, I got it back. All right, so your new y's are -2, -1, 0, or your x's, I'm sorry, your y's are -3, 4, 0, 3. Your domain is -infinity, infinity. Your asymptote is your k. So the range is -1, infinity. Your asymptote is y equals -1. That's a shift left 1 and down 1, and there is your graph. Your asymptote is right here. Never going to hit that -1, y equals -1. So for this one, your new x is -1, 0, 1. Actually didn't change because there's no h. And then your new y is 3/2, 3, and 6. Your domain is -infinity, infinity. Your range is 0, infinity. Your asymptote is y equals 0 because there's no k, and this is a stretch. Last one, your new x is -3, -2, -1. Your new y, 2.5, 2 1/4, and 2 1/4. There should be a quarter. So domain is -infinity, infinity. Range is 2, infinity, because there's your k, there's your asymptote. Y equals 2. It's left 2, up 2, and it is compressed. Number 6. This is exponential growth. So y equals 70 times the quantity of 1 plus 1800ths, all to the 4th power. When you actually simplify that, it's about 135 sea otters. Number 7, 8,000 times the quantity of 1 minus 600ths to the 10th power gives you about 4,308 fish. And then number 8, y equals 1,600 times 1 plus 500ths to the 20th power gives you about 4,245,000. Hold on a second. No, $424,527.63. See, that's what happens when you don't put your commas in. All right. The next part is determine whether this is an arithmetic, geometric sequence, or neither. And then I gave you the common difference or the common ratio. Number 1 is arithmetic. The common difference is 6. 2 is geometric. Common ratio is 1/2. 3 and 4 are both neither. 5 is geometric with a common ratio of 6. And 6 is arithmetic with a common difference of -2. The next one says you need to find out what the ratio is, the common ratio, and find the next terms, the next 3. Number 7, 24 and 4/5. Number 8, 54, 162, 486. Number 9, 864, -5,184, and then positive 31,104. Number 10, 1/10, 1/20th, 1/40th. Number 11, -192, -768, and -3,072. Number 12, 1/3, 1/18th, and 1/108th. 13, you have to write an equation for the nth term of each sequence, and then you have to find the term they ask you to. So 13 is a sub 1 equals 3 times -8 to the n minus 1 power. The 9th term is 50,331,648. 14, the nth term of this sequence is is 9/16 times 2/3 to the n minus 1 power, and the 7th term is 4/81. 15, the nth term is 1,000 times 1/5 to the n minus 1 power. The 5th term is 8/5. Number 16, the nth term is -8 times 1/4 to the n minus 1 power. The 8th term is 1/2048. 17, the nth term is 32 times 3/2 to the n minus 1 power. The 6th term is 243. 18. The nth term is 3/10 times 10 to the n minus 1 power, and the ninth term is 3 million. All right, calculating compound interest. How many times a year is the interest calculated if the problem says monthly? Well, that's 12. B, quarterly is 4, and C, semi-annually is 2. The formula for compounded interest is that, compound, not compounded. P is the starting amount, R is the rate of interest, and N is the number of times compounded. Tim invests a savings account that grows at 2%, compounded every 3 years. Here's the equation. A equals 120 times the quantity of 1 plus 2/10 over 12 to the power of 12 times 3. It's about $127.41. And technically, you can only compound interest, not people. So I really don't like 4 and 5. And you really can't compound when it decreases. So we're going to let go of 4. 4 is not legit. 5, it's compounded annually, so it's once. A equals 1,500 times the quantity of 1 plus 7/100 over 1 to the third power. That's about $1,837.56. Part 2. All you need to do is write the equations. They seem to like semi-annually. So A is $7,300 at 7% compounded semi-annually for 3 years. Should be A equals 7,300 times the quantity of 1 plus 7/100 over 2 to the 2 times 3 power. B is A equals 1,800 times the quantity of 1 plus 9/100 divided by 2 to the 12th power. C, $1,030 times the quantity of 1 plus 4/100 divided by 2 to the 6th power. And D, 1,500 times the quantity of 1 plus 7/100 to the third power. Annually is just once. You didn't even need to put those ones in there. And that is it.